Hello everyone. In this video, we would be discussing question 3 and 4 of IBSL 2020 Chemistry Paper 2. Let's start with question 3. In this question, we need to find this value of the combustion of propane, the standard enthalpy change using section 11. Section 11 basically contains the bond enthalpies, and I've already listed down the specific bonds which would be formed or broken in this reaction. So delta H is basically summation of bonds broken minus summation of bonds formed. Okay, now summation of bonds broken would be, we see that there is C3H8, so there are 8 CH bonds, so 8 times 414. Now there are 3 CC bonds, so 3 times 346, and there are 5 OO bonds, so it's 5 times 498. So upon calculating, this comes out to be as 6840 kilojoule. Now summation of bonds formed would be, we see that 3 moles of CO2 is present. Okay, so that's basically 6 moles of CO bonds, so 6 times 804, and we see 4 moles of H2O is produced, that is basically 8 times OH bonds. Okay, so this comes out to be as it comes out to be as 8528. So our delta H would be bonds broken minus bond formed. This is bonds broken, this is bond formed. Okay, both have the same unit of kilojoule per mole. So 6840 minus 8528. So our answer is minus 1688 kilojoule per mole. This is the final answer. Now in the next part of this question, we need to calculate delta H, or the enthalpy change, using section 12. Section 12 actually contains the enthalpy of formations. So for this, delta H is basically summation delta HF products minus summation delta HF reactants. Okay, for products we have 3 moles of CO2, so 3 times minus 393.5. We have 4 moles of H2O, so 4 times minus 241.8. Minus, for O2 it's 0. Okay, so 5 times 0 is basically 0. I'm neglecting that. And we have minus 105. Okay, so on calculating, what we get is in the next question, we need to highlight why an increasing temperature increases the rate of the reaction. So basically, when we increase the temperature, what happens is more number of molecule will have energy greater than that of activation energy. Okay. Secondly, what happens is when we increase the temperature, what happens is that the velocity of the particles moving will increase. That will basically increase the number of collisions per second, or number of effective collisions. As a result, the reaction will be faster due to these two effects basically. So ensures more number of molecules have energy greater than activation energy. Also, due to increase in velocity of molecules, the number of effective collisions per second will increase. Okay, so this is the last question. In this last question, we need to find out the relative volatility of propanone or propanediol, or which one is more volatile. So propanone basically has the following. Propanone, the structure is this thing, and propanediol has this structure. So propanone can have only two intermolecular forces. First is the London forces, and second is a dipole-dipole. I mean, it's a dipole interaction. Okay. This thing cannot have a hydrogen bond because for a hydrogen bond, hydrogen should be directly attached to an oxygen. For propanol, we will have three intermolecular forces. First is the hydrogen bond, okay, because this hydrogen is directly attached to this oxygen. So any hydrogen that is attached to an oxygen can produce hydrogen bonds. Okay, there would be an intramolecular hydrogen bond here. Okay, then we will have dipole-dipole interaction or dipole interaction, and we will have London forces. Okay, we see that there are more number of intermolecular forces for propanol as compared to propanol. As a result, what we can say that the molecules will be tightly held to each other in propan-2-ol as compared to propanol because of more intermolecular forces. As a result, the volatility will be low. Okay, so hence volatility of propanol will be more. Okay, so lesser number of intermolecular forces means the volatility will be more, because as the number of intermolecular forces increase, for the tendency of something to get into gas phase will decrease. Okay, so yeah, that's it for this video. Hope you like the solutions, and don't forget to like this video and subscribe to our YouTube channel. Thank you so much.